Hi, welcome to the video on the homework on graphing exponential and logarithmic functions. I'll be going over number 5 and number 6 to help you get a better idea of how to solve these problems. The first thing you want to do when you approach these problems is identify the parent function. So here we're given a logarithmic function, so my parent function will be y equals log base 2 of x. Basically, I'm just ignoring all the transformations, and then I'm going to decide, well, what transformations did I complete on this parent function to obtain the transform function. So now I'm going to look at my given function and see what's going on. The x minus 2 tells me that this is a horizontal transformation since it's in the arguments of the function, the logarithmic function. And I'm subtracting 2, which really means that I'm going to be moving to the right 2. So this is a horizontal translation to the right 2. The negative in front, or opposite, tells me that I am reflecting. And since this is outside of the log function, I know that this is a vertical reflection. And finally, the plus 1 tells me I'm translating up 2. Okay, so now we're ready to actually look at some points and how they've been transformed. So I first want to start with my parent function. The parent function was y equals log base 2 of x. But it's going to be easier for me probably to rewrite this as an exponential function, or an exponential equation, sorry. So the way that I would write that is I could exponentiate both sides. So raise 2 to the power of each of these. So this is another way of writing that is 2 to the y equals x, since 2 raised to log base 2 of x is just x. Now I can make my t-chart. And if you notice from the way that this equation is written, it's going to be easier for me to substitute in numbers for y and then figure out what the x coordinate will be. So let's just use the numbers 0, 1, 2, and 3. 2 to the 0 power would give me 1. 2 to the first power gives me 2. 2 to the second power gives me 4. And 2 to the third power gives me 8. Now I have my parent function and its coordinates, so I'm ready to look at the transformations that are occurring. So now we're going to look at our transformed function. And this is the one that we're actually being asked to graph. So y equals opposite log base 2 of x minus 2 plus 1. So I'll come down and make another t-chart, and I'm going to transform each of these coordinates. The first thing I want to do is look at what happens to the x-coordinates. I said that for the x-coordinates, we need to move to the right 2, which means I'm adding 2 to each of these coordinates. So 1 becomes 3, 2 plus 2 gives me 4, 4 plus 2 gives me 6, and 8 plus 2 gives me 10. Now let's look at the y-coordinates. If we remember from what we said before, the y-coordinates first have a vertical reflection, so reflection, and then we're also going to move it up 2. Remember that you're always going to do reflections and dilations first before you do translations. So when I am mapping each of these y-coordinates, I need to reflect first and then move up 2. So 0 reflected across 0 is still going to be 0, but I will move up 2. So 0 plus 2 gives me 2. Now the 1, when I reflect it, becomes negative 1, and then I need to move it up 2. So negative 1 plus 2 gives me a positive 1. The 2, again, it's reflected, so negative 2 plus 2 gives me 0. 3, it's going to become negative because it's the opposite. It's reflected, so it's negative 3 plus 2 and negative 1. Now I have 4 coordinates for my graph that I can plot. So I'll plot each of them. 3, 2, 4, 1, 6, 0. Count that out. And 10, -1. Before I connect the dots, I really want to make sure that I move the asymptote appropriately. If you recall from our magic tracing paper, we know that a logarithmic function will have a vertical asymptote. So I need to see, has anything changed? It would be at x equals 0, but since I've made a horizontal translation to the right, now it's at x equals 2. Then I will dash my asymptote. So I remember how I need to curve my graph. And remember, it's going to approach this line as close as possible, but it will not pass it. Another way to think about where the asymptote will occur is I know that you can never take a logarithm of something that is negative or equal to 0. So I want to determine when does this argument equal 0. So when does x minus 2 equal 0? Well, that has to be where x equals 2. So that is where the function is undefined, and thus there's an asymptote there. Looking at my graph now, we can just fill in some of the rest of the information. The domain of this graph goes from -2 to infinity. Since there's nothing on the left-hand side, it's undefined there, because you would try to evaluate a logarithm of a negative number or a number that equals 0. You can't do that. The range, however, is all real numbers. So in interval notation, I would write -infinity to infinity. And the critical points are just key points coordinates that I will copy from my transformed function. So I can just write in a couple. And there you have our beautiful graph. Make sure that you have extended and put arrows on the ends of your graph.